Welcome to welcome to Spark Learning session. Today I'll be talking about linear regression project. This project is about Hyundai Industries. Let me go over the project details before we dig deeper into the weeds. It says, congratulations, you have been contacted by Hyundai Heavy Industries to help them build a predictive model for some ships. Hyundai Heavy Industries is one of the largest ship manufacturing and builds cruise liners. We have been flown to their headquarters in Ulsan, South Korea, to help them give an accurate estimate of how many crew members a ship will require. They are currently building a new ships for some customers and want to create a model and use to predict how many crew members the ship will need. Here's what the data looks like so far. This is the data description that is been given. And the file we have been given is cruiseshipinfo.csv file. Now let's get started. Let me start importing some libraries for PySpark. Import PySpark, find Spark. Let me copy and paste this whole thing so that we don't have to do it all over again. I'm going to run it and let's see what we get. It's running right now. Let me start typing some command to import the file spark.readcsv, and the file name is cruiseship.info.csv. Infer schema true. Header true. Let me run this. Infer schema. Let me run it again. What's giving me error? It is giving error because it's a rod. It's not read, it's a rod. Now let's run this again. Read. Infer schema. There's no space after comma schema. Let's run this again. Let me just copy and paste it from my other screen so that I don't have to keep doing this. I hope this runs this time. It runs. Now let's see what kind of schema does this have? Print schema. Let me run this. It has some column names. Here column names, ship name is string, cruise line is string, age is integer, tonnage is double, passenger is double, length is double, cabin is double, passenger density is double, and crew is double. These are all numeric except ship name and cruise line. Now we have that info. Let me check the few lines and get details of the lines itself, such as let's say I want to iterate through the each line item, each items in the data frame. How do we do that? Let me show you. For ship in df dot head, this will give me 5 lines from it, and I'm going to iterate through them. Print ship and print /n. Now we have this row. It splits out a row for each of the row data frame, and we see that as a ship name, cruise line information, age, tonnage, passenger, cabins are all numeric decimals, continuous variables. Now, what we need to do here is we want to deal with the cruise line as a category. Cruise line is a categorical variable, and we want to deal with that. We want to make something like a numeric. Let's For that purpose, let's try to group by cruise line information. Cruise line let's group by cruise line and do count and show. Count, I made a mistake here. It should be bracket after that. Count. Now we have some query running in the background. Next step is to use a string indexer to make the categorical variable into numeric one. We use indexer for that. Indexer equal to string indexer. String indexer input column, that would be cruise line. Let me copy and paste it so that I don't make any mistakes here. Output column, that will be cruise category. That's our desired name for the output column. Next step, we will create a variable called indexed, which will be equal to indexer. This is a machine that's going to fit data frame, or that's going to add a column to a data frame with this information. Now we'll transform. We'll create a new variable, again the index, and use the transform function to transform this data frame, and we'll look at the first few columns from this, first few rows from this data set. 4. Let's look at the 4 rows from the data set and let's see what we get at this point. We made some mistake. Let's fix that. String indexer model has no attribute called transform. We need to put F here, and let's try to run it again. Let's fix that. Indexed There you go. We got what we need. Now let's go through the some column names. Let's list out the column names for this data set. Indexed columns. Next step, we need to create a vector assembler, which is already here, and output a featured column using this column names: age, tonnage, passenger length, cabin, passenger density, cruise category. These are the columns we need to create a feature vector called features, and this is done by vector assembler, and the instance of this is called assembler. We'll use that to create an output data set we need that would use this assembler machine to create the data set as required. It says assembler is not defined. I forgot to run this statement. Now let's run it again, and what we get. It works. Now moving on to a next step, we have to select two rows or two columns from this output. One is features and one is create, because those are only two columns we are interested in. Assembler has many columns, but those are two columns we are interested in. That's why we're gonna select those two. Output dot and select these two columns for our task. Features, crew dot show. Let's see what we get. There you go. We have what we need. Now let's assign this dataset into a variable called final data. Final data, and assign this into that variable, and remove the show because we are not showing, we are just putting it into a variable. Next step, we need to generate our test data and train data. Train data is for training, while test data is for testing our model. Test data, final data, random split. We'll do 70-30 split here. 70-30 split here. Now we have our training and testing data. We'll try to describe the data and see what kind of statistics this data have. Train data, describe, and show. It seems this train data has 98 rows. That's a count of the out of the rows it has, and a mean. It has mean, standard deviation, minimum. This is for crew. The mean crew is 8, standard deviation is 3, minimum is 0.59, and maximum is 21. Let's do same thing for let's do similarly for our test data as well. Let's add some test data here. Let's do something similar for test data as well. And let me copy and paste this test data so that I don't have to type it. And there you go. For test data, we have a count as 60 rows. Mean is 7.8, max is 19, minimum is 0.6. This is a random selection from the final data set. Now next step, we have to create a model. Let's name this model as a ship LR, and this model is linear regression model, which takes the input call label column called crew. That's the output this model will generate, crew. And the input column is its features. Since it's a standard, we don't need to specify it again. Let's run this. It runs. Now we need to train this model with our training data set. Trained ship model. Ship lr.fit train data. Now we have the train model. We need to get some results from this model. Like we have to evaluate this model using a test data, and that's what we're going to do now. We're going to do ship results. Ship results trained dot train model train ship model evaluate. We need to evaluate this model because we already created this model, fitted this model. Now let's evaluate using a testing data. Let's see what we get. We made some mistake here. Let's fix this mistake and run this again. Ship LR is not defined. I think I forgot to run this. Now this also works. I ran this ran successfully. Now so let's evaluate this model. There you go. Once our model has been evaluated, we need to see some results from evaluation. Ship results dot what we want to see. We want to see, let's say, root mean square error 1.16. This for crew. It's not too large. It's really in reasonable limit because we have a crew count up to 60, 19, and 1.16 is really reasonable. R square. Let's see R square of this ship results. Ship R square means how well the variation in label is explained by the explained variable. Let's run this again. R square. It does not run. Okay, now it runs. Now let's print out some other uh, metrics such as ship results dot mean square error. All control and enter. All control and enter. Issued. All control enter. There you go. 1.316. There's a mean square error for this. What is mean absolute error? Let's check that also. Ship results, mean absolute error. Let's run this also. Now we need to define a correlation between two things, crew and passenger and crew cabin. How do you do that? Let me show you. Let's start with crew cabin, passenger and crew. DF, select correlation, crew. Let me just copy and paste this thing so that I don't have to type the whole thing. There you go. Crew and passenger have correlation. And secondly, let's do the crew and cabin. They also have a high correlation. That's why we are getting such a good mean square error for this result. Let me quickly summarize what we discussed today. We work on linear regression project for Hyundai Heavy Industries, and our business problem was to predict the number of crew needed for a new passenger ship. We are given a data set with, that that was called choose ship info, and we use data set to create test data and training data, and we used Spark to create a linear regression model which we trained on training data and use testing data to evaluate the model. When we evaluate the model, we got really good results. That's all for today. I will see you in next learning session. Thank you so much.